Okay, we're going to cover section 2.7 and we're going to answer the question of how do you graph absolute value functions. Okay, so we'll start with the parent function. If you remember that term, that's the simplest function in a family of functions. So we're talking about absolute value. So the simplest absolute value function would be the absolute value of x. So let's graph that by simply making a table. X, y values, let's go from -2 up to 2. Okay, so if I substitute -2 in there, take the absolute value of -2, I get +2. This is going to be +1, this is going to be 0. If I absolute value of positive, it stays positive. Let's see what we get. -2 is 2, -1 is 1, 0 is 0, 1 is 1, 2 is 2. Graph looks like this. It's the shape of a V. Okay. On the left side, the slope of that is 1, and the slope on the left side is -1. Down 1 over 1. Okay, so we are going to look at what happens when a graph is translated. Translation changes a graph's location or size. Okay, so let's start with a simple one. Y equals absolute value of x plus 2. Okay, so and then we'll compare it to this one. So let's make a table. Okay, so -2 absolute value is 2, and then when I add 2 I get 4. -1 becomes 1, plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3. Absolute value of 2 is 2. 2 plus 2 is 4. So let's see, -2, -1, 0 is 2, 1 is 3, 2 is 4. Looks like this. How is the graph translated? Well, you can see comparing this one to this one, it was moved up 2, and that was because of the +2 at the end. So in general, if I have a graph of y equals absolute value of x plus some value k, we'll just use k as the variable for a vertical shift, moves graph up k units. Okay. Predict what do you think would happen if it was -2? You would move the graph down 2 units, it would be down here. Okay. Let's try the next one. So that's the first one. The next translation example, y equals absolute value of x -3. Okay, so that's inside the absolute value. So think about what you think might happen there. Let's make a table. I'm going to go from 0 to 5. Let's see why in a minute. If I plug 0 in there, 0 minus 3 is -3. When I take the absolute value of that, I get +3. 1 minus 3 is -2. Absolute value is +2. 2 minus 3 is -1. Absolute value is +1. 3 minus 3 is 0. So we get 0 there. 4 minus 3 is 1. 5 minus 3 is 2. So I got 0, 3, 1, 2, 2, 1, 3, 0, 4 is 1, and 5 is 2. So what you see is happening here, oops, the graph has been shifted to the right 3 units. Okay, so in general, if I have absolute value of x minus h, and we use h as a horizontal shift, moves graph to the right h units. Okay. That's kind of the opposite maybe of what you would think. You'd think because it's minus 3 it would move it to the left, but it's the opposite here for a horizontal shift. So if it's x minus some value, it moves it to the right. If it was a plus 3, it would move it to the left. Okay, so let's combine that now. Let's do another one. And combine these two. So this is number 3, I guess. X plus 2 minus 4. Okay, so kind of think about what you think is going to happen there. And then let's make a table. Okay, so let's go for... Okay, so let's try negative 3 plus 2 is negative 1. Absolute value makes it positive 1. 1 minus 4 is negative 3. Negative 2 plus 2 is 0. Absolute value is 0. 0 minus 4 is negative 4. Negative 1 plus 2 is 1. Absolute value gives you 1. 1 minus 4 is negative 3. 0 is going to give me 2, so that's negative 2. And then 1 plus 2 is 3. 3 minus 4 is negative 1. Let's see if that gives me enough data points here. Negative 3. Maybe we should have added negative 4 in there. If I put negative 4 plus 2 is negative 2, absolute value gives me 2. 2 minus 4 is negative 2. That gives me one more point there. So where was this graph shifted? It was shifted 4 units down and 2 units to the left. Okay, the lowest point on the graph, the bottom of the V, is called the vertex, and that coordinate is negative 2, negative 4 in this case. Okay, so that gives you an idea. If we have a general equation with an h and a k in it, the h is negative 2 and the k is negative 4 in this case. Moves it back 2, down 4. Okay, one last thing before we get into this general equation. I might have introduced that a little too soon. Let's see. What happens if I have a number in front of the absolute value? So let's make a table again. So absolute value of negative 2 is 2. 2 times 3 is 6. This is going to give me 1. So it's 3. 0 times 3 is 0. 1 is going to give me 3. 2 is going to give me 6. So negative 2. Go into this one a little bit. So this graph is going to look like this. So what did the 3 do to the graph? Looks like it made it skinnier, or made the lines steeper. Okay. Notice what the slope is here. 3 over 1. The slope is 3. That's also the number in front of there. So it's the same as the absolute value graph, only it's stretched. vertically. Okay, so we are going to use what's called a general equation that looks like this. Okay, we know what the A does. The A is our slope, our stretch. So I want to write that down. Slope of the graph. The H is the horizontal shift. And the K is the vertical shift. Okay, and combining those, the coordinate H, K is my vertex. So this is going to make life easy to graph these equations. Okay. So let's graph one. Absolute value, or y equals -1/2 absolute value of x plus 1 minus 2. Okay, so we don't want to have to make a table for every graph we graph, if we can find a simpler way to do it. So we're going to use this general equation idea to do that. Okay, we've investigated this and we found that if we add a number at the end, it moves it up or down. If we subtract inside the absolute value, it moves it right. If we add, it moves it left. Combining that, we get our vertex, and the A stretches the graph. Okay, so in this case, looks like our graph is moving down 2, it's moving to the left 1, and it's stretched. And I wonder what this negative does, and we'll find that out in a minute. Okay, so in this case, the vertex of my graph is HK. So in this case, H is actually -1. Think of it as an opposite. In order to have x minus H, this would be x minus -1, which makes it +1. So -1 is my H, -2 is my K. So that's my vertex. Okay, -1/2 is my slope of the right side of the graph. So if I go down 1 over 2, there it is. Okay, so that's the right side of my graph. So this graph actually opens down. And if I flip this over to the other side, because this graph is symmetric, I can flip this point over to the other side, and I've got my other point, I've got my graph. Okay, let's just do one more quick example. Let's go to absolute value x minus 3 plus 1. So you try that one real quick, pause the video, and then we'll go through the answer. Okay, let's see what we've got. So the vertex is 3, 1, H is 3, K is 1, and the slope is 2. Okay, this is my line of symmetry. Slope is 2, so up 2 over 1. Flip that over to the other side. You got it. So that's how we're going to graph these absolute value functions.